Dear students, welcome to another sessions of operating system. In this lecture video, we are going to discuss about process concept. This is Dr. K. Praveen Kumar, Assistant Professor, Department of Information Technology, KITS Warangal. In this process concept, we are going to discuss about process concept, process scheduling, and inter-process communication. So objectives of this topic is to introduce the notion of a process, a program in execution, and which forms the basis of all computations. To describe the various features of process, including scheduling, creation, and termination of communication. To explore inter-process communication using shared memory and message passing. First one, process concept. An operating system executes a variety of programs like batch systems, we call it as jobs, time shared systems, user programs, or different tasks. So the term job and process are almost interchangeable. Job or process. What is process then? A process is a program in execution. Process execution must progress in sequential fashion. One by one, the process will be completed. Multiple parts. The program code, it is also called as text section. Current activity including program counter, process registers. In this process, stack. The stack contains temporary data. In that, it is going to store function parameters, return address, what it is going to return, and the local variables which it is going to use. Data section, which contains global variables. Heap contains memory dynamically allocated during runtime. So in this process concept, program. Program is a passive entity stored on disk, and process is an active entity. Program is a passive entity, process is an active entity. Program become process when executable file loaded into memory. A program become process when the executable file loaded into a memory. For example, let us say you have written some program in your C language. You will write all the instructions that become the program. When you are trying to compile it, then that will be loaded as an executable file. Then it become a process, and it become a process. Execution of program started via GUI, mouse click, command line entry, or some other ways like mouse click enters or keyboard or joystick. That will be the execution, initiation. One program can be several processes. Yes, obviously, for example, if you're writing a project code, then when you're writing a C program, you will create a file, you will open file, you will write the contents into the file, you will save the file, you will close the file. So each and every open is a task, create is a process. Copying the contents into that file is a process, right? So program may be one, the process may be several, right? So we can consider multiple users executing the same program. Yes, you can, right? So process, when process is in memory, generally it will be like this. So it will be having a stack It is going to store all the variables, and heap, that is heap data structure we use here. Data, whatever the parameters you are passing through, the data and the text which you have entered. Right. As a process occurs, it changes its states. So what are the different states of a process? So a process will have the following states. First one, new state, then running state, waiting state, ready state, and terminated state. So there are 5 states of a process. New state, that is the name itself, it is saying that is the process is being created. Running state, instructions are being executed. Waiting state, if the process is waiting for some event to occur, then it is called as waiting state. Ready state, the process is in waiting to be assigned to a process, then it is ready to complete its task. Terminated state, so if the process is completed, its complete execution, then we call it as terminated state. So this is the diagram for process states. If you observe here, so initially a process will start by the time it is new, then it will be admitted in ready state, then whenever it is running by using the schedule dispatcher, it will become in running state. Then after running state, if there is no interruption, then it will be terminated. If there is some interruption, then it will become ready state, and sometimes running state too, it will go for waiting state if there is an interrupt or event to wait, IO wait, then it will be in waiting state. Then after it gets that IO devices, then it will be in ready state. From ready state to again, it will go to the running state to terminated state. So in these 5 states, your process is going to be executed. This one is process control block. So we came to know that process states. What is this process control block? That is how these processes are controlled. So information associated with each process, also called a task control block or process control block. So there are different process states, running and waiting state, etc. There is one more thing called program counter, location of instruction, next to execute. What is the next program to execute? And CPU register contains of all process centric registers. CPU scheduling information, that is priorities, scheduling queue pointers, like all comes under scheduling information. Memory management information. This CPU process control block will also have memory management information, which memory is allocated to that particular process. Accounting information will also be managed, that is how much CPU utilized, what is clock time elapsed since start, and what are the time limits. IO status information will also be managed by PCB, that is IO device located to process list of open files. So right, so this is process control block, process state, process number, program counter, register, memory management, list of open files, and so on. So these are the registers. This is completely, we call it as process control block. Process control block. Right. CPU switch from process to process. CPU switch from process to process. So in this way, it is going to start. See, this is process 0, P0, and this is process 1. So whenever it is executing, what your operating system is going to do? Your operating system is going to give these process blocks to process 0, PCB 0, right? Save states in PCB. By the time process 1 is idle, so whenever this process 1 wants to execute, so then this will become idle and it reload from PCB1. So PCB1, it will be having PCB1 process control block, it is having PCB0, will reload, then again it will be executed. After execution completes, it saves the executed one in PCB1. Then again it will be in idle position. Whenever process 0 wants to execute, it reloads from PCB0 and it will complete its execution. So in this way, the process your in operating system or CPU will switch from process 0 to process 1 and process 1 to process 0 simultaneously. The next one we have to learn is threads. So process has a single thread of execution. Every process will have single thread of execution. Consider having multiple program counters per process. For each and every process, there are multiple program counters. Then multiple locations can be executed at once. So multiple threads of control will become threads and then have storage for thread details. Now, till now, PCB we have done. Now, to manage this thread details, we will have multiple program counters in PCB. So this is process representation in Linux, how you are going to represent process. These threads you are going to learn in detail in the next chapter. So this is represented by C structure task struct. So this is task struct, it is having a structure like PID. One is process identifier, that is T underscore PID. Login state, that is state of the process. Unsigned int time slice. Unsigned int time means this is scheduling information. So when it is process having how much time, that is time slice. So process parent, that is when you are writing like star parent, that is the process parent, and process children, and it is list of files. And struct is address space of this process. So this is process information. It's one state to another state it is moving. Yes, you can see here. So generally this is a process representation, whereas in Linux, so this all comes under Linux. Right. So with this, we'll stop here, and in the next chapter, next video, we will see the continuation of this concept, chapter 3 concepts. Thank you.